Good evening. This is Ms. Thompson, and today we are talking about topic 1.6b, which is composition of functions. If you don't remember, we got this in class on the back of arithmetic combinations. And so if you're looking for these notes, they're on the back of these. And we're essentially going to talk through what composition is, and then 3 examples of how to do it. Composition is something you've already done because you all know how to use a function with an input that is a variable. And we're essentially doing that with an extra step and a little bit of understanding on top of it. So here's what composition of functions is. The main idea is that a composition of functions is when one function is used as the input for another function. So one function is used as the input. So our notation we usually see when we have composition is it looks like it says fog. It does not say fog. So even though it might look like it, that is not what it says. This is just a tiny little circle, an open circle. I'm not actually sure even what the symbol is called, but it's F composed with G is how we say it, or F of G of X. F of G of X. And what this means, like I said, it means that one function is used as the input for the other. So F is my first function. And in F, instead of just putting F of X or F of 2 or F of 9, I'm actually putting G of X inside it. So G of X is my inner function or my input. And F of X is my outer function. So G of X kind of go as my input to my function F. It's a little strange. So I think the easiest way to think about this is to do some examples. So we're going to do some examples down here. I've got 3 functions. I've got F of X is 2x plus 1, which will be in blue. G of X is x squared, which will be in red. And H of X is 4x, which will be in yellow. And we're going to do 3 different compositions of these. So our first one here is F of G of X, or F composed with G of X, or F of X composed with G of X. Lots of ways you'll hear it. And I'm going to start by writing out exactly what this is in function notation. So moving from this, my fancy function notation, to my input-output notation. So I'm going to start with F of G of X. I know F is my outer function. And my inner function is G of X. So F is my outer function and G of X is my inner function. And then I'm going to take that and start to fill in my function pieces. So what I'm going to do first is I'm going to leave my function as F, because I know what F is. I can come back to that later. But I'm going to say, instead of writing G of X, I'm going to replace it with what my rule for G of X is. So F of G of X is the same thing as F of X squared, because X squared is G of X, and so I'm using that as my input. Now I'm gonna kind of ignore all the things I've done before, ignore compositions, and just think, what is F of X squared, right? If my input is X squared, how do I evaluate my function? How do I follow the rule? And F, we said, is 2x plus 1. So it's 2 times my input plus 1. And my input in this case is x squared. It's following me around from this G of X. Once I get here, my goal is just to simplify. So I'm going to remove my parentheses, and this is 2x squared plus 1. So that is my composition of function. Again, we started with moving into function notation. So I have an outer function and an inner function. Then I'm replacing my inner function, because I know what that is. In this case, it's x squared. And then I'm just evaluating F at x squared. So F is 2 times my input plus 1, and my input is x squared, and I simplify. All right, let's do our second example. This one says G of H of X equals what? G of H of X. So again, the first thing I'll do is I'm going to translate this so I can see my inner and outer function. So this is g of h of x. G of h of x. And then I will, again, keep g the same, but instead of h of x, I'm going to write down my rule. H of x we have is the square root of 4x. Now that I've got an input that's not a function anymore, it doesn't have my f in there, and I've got g on the outside, now I can say, what is the rule of g? G takes my input and squares it. So I'm going to take my input and square it. And then I'm going to say my input, we know from our previous line, is the root 4x. Perfect. Now all I have to do is simplify. The square root of 4x squared, our square root and our squared actually undo each other. And so my answer is just 4x. Answer is just 4x. All right, last but not least, this is a weird one. This one actually has f of x. We're composing a function with itself, which is a little weird, but I'm just going to follow the same rule I have as before. So my first thing I'm going to do is I'm going to move this into my notation so I can see my inner and outer function. So I have f of x. A little strange. And then I'm going to leave my outer function in its notation, but I'm going to replace my inner function with the rule. And f of x we know is 2x plus 1. So I'll write that inside. And now what I want is I want to take my function f and I want my input to be 2x plus 1. So my function f says 2 times an input plus 1. So down here I'll do 2. I'll leave a space for my input and I'll add 1. And my input in this case is also 2x plus 1. It's a little strange, but I can still put that in for my input. And now I want to simplify. So now I'm done kind of evaluating function, and now I can just simplify. So I've got 2 times 2x and 2 times 1. That makes 4x plus 2 plus 1. And if I combine like terms, I get 4x plus 3. Oops, sorry, I couldn't see the end of it there. All right, so function composition. When I think about how to do this, I'm thinking about a couple main steps. First, I am moving from my fancy notation to seeing my inner and outer function. So I'm going to write my question, write my problem, so I can see inner and outer function. That's this step here, writing it out so I can see it. Then I'm going to replace my inner function with the rule. So I replace my inner function, x squared, g of x is just x squared. Then I'm going to evaluate my outer function. So f of x squared, so 2 times the input plus 1, and x squared is my input. And lastly, I will simplify. So if you need to come back to this, these steps can be very helpful, and we'll practice these in class as well. All right, best of luck.